launch pad, we have the large truss structure next to the rocket. That's part of the transporter erector, or TE. We use the TE both to roll the rocket out to the pad and to raise it to its vertical launch position. The TE also routes the vehicle's fluids, power, and telemetry umbilicals from the ground to the rocket and the satellites. Now, in callouts over the net today, you may hear the vertical portion of the TE that's right alongside the rocket. That's referred to as a strong back by the launch team. Now that you're a little more familiar with the vehicle, let's learn more about today's payloads.
In a world where change is faster than ever before, the pace of innovation is evolving and accelerating. To support the era of digital transformation, artificial intelligence, and hyperconnectivity, the intelligent systems that enable all of this progress require a platform to innovate. One that meets the most sophisticated demands for high-performance network services. At SES, innovation is part of our DNA. It drives us and helps us to bring new stories to life. And our O3b mPOWER story is just getting started. The next pair of O3b mPOWER satellites is ready to travel through space to join our medium Earth orbit satellite constellation 8,000 kilometers away from Earth's surface and help continue delivering high throughput, flexible and reliable network services across the globe. With our O3b mPOWER system becoming operational earlier this year and deploying services across Asia-Pacific, Africa, the Middle East and Latin America, offshore platform workers, remote communities in the Galapagos, telcos in disaster-impacted areas in the Pacific, and governments carrying out critical missions, all are now relying on our second-generation MEO constellation to drive transformation and enhance their connectivity experience wherever they are.
We already have 6 of these MEO mPOWER satellites out in orbit. They actually were launched and went to service in April of this year. So this is quite new constellation. Ever since we launched it, we had huge successes and a lot of customers trying to use this particular constellation. Why? Because this is one of the most technically advanced constellations out there. It's also the most flexible one, which means you can program and reprogram these satellites depending on the use and the mission that you want to have them. With these 2 additional satellites, we'll be increasing the capacity of this constellation significantly, up to 50% improvement of capacity, which means we can do more services. With this constellation, we're able to connect remote islands. We're able to connect enterprises that have remote locations to their central compute and store environment, to the cloud environment. We're able to give the governments the capability to execute mission-critical operations, which is why we have a big deal with NATO, led by US and Luxembourg, to leverage this constellation where they need it, even in the most harshest environments. By adding, we're creating more capacity, and we're able to give our cruise customers, our aero customers, our enterprise customers what they need. Enjoy the show, and again, thank you to our partners, and especially SpaceX, who's given us a ride today as well. Thank you.
We're at T-minus 4 minutes, 36 seconds, and counting from the liftoff of Falcon 9 from Complex 39A at the Kennedy Space Center in Florida. The good news is that the weather has been given a go for launch. The clouds have moved just far enough out of the way. And right now we're getting ready for the call-out that strong back retraction is underway. There it is. Now that means the clamps around the second stage will be beginning to open. The hydraulics will open them, and that's a process that takes about 20 seconds. And the strong back is that vertical structure, as we mentioned, of the transport erector, and that carries propellant, electrical, and gas up to the second stage and to the satellites. You can see the clamp arms are coming open. Now that the arms are open, the strong back will begin reclining. It moves to a position about 2 degrees from the launch vehicle. Once the Falcon 9 commands the liftoff, hydraulic cylinders down at the bottom of the strong back, that'll pull the rest of it away from the launch vehicle to a position about 45 degrees above the pad deck. And you can see right now the close-up camera showing you the payload fairing and the second stage. Strong back recline looks like it is complete. We're a couple of degrees away. Next major activity that we should hear call out is stage 1 LOX load is in closeout. That's just after T-minus 3 minutes. And that would be the announcement that liquid oxygen loading is complete on the first stage.
Stage 1 LOX load complete.
And now we've heard that call out. Stage 1 liquid oxygen load is complete, coming up on the 2.5 minute mark before launch. Next up, inside T-minus 2 minutes, we'll hear a similar call out that stage 2 liquid oxygen load is in closeout. That means it's complete. And at that time, the first and second stages will contain nearly 1 million pounds of kerosene fuel and liquid oxygen. You can see the white clouds right now around the vehicle. That's formed as the chilled gas above the liquid oxygen tanks. Yeah, we've heard the call out. So we are now fully loaded. As I mentioned, the clouds that you can see around the vehicle, that's the gas above the liquid surface in the tanks, gets chilled down, and when it's vented overboard to maintain pressure in the tank, that means that chilled gas comes into contact with the warm, moist Florida air, and it condenses the water in the air to form the clouds that you see on your screen. Next major activity will be T-minus 60 seconds. That's when Falcon 9 will be in startup. The rocket's autonomous internal flight computers will have taken over the launch countdown. The call out you just heard now, ground gas closeouts. We're venting down the lines on the strong back. Make sure that they're empty before the Falcon 9 lifts off. As we get into the final minute, the terminal sequence, inside of T-minus 2 seconds, we'll light the Merlin engines. But right now, as we wait for the call out at T-minus 1, everything continues to be go for launch.
Falcon 9 is in startup.
Falcon flight computers now controlling the launch vehicle. Ground computers are doing the last steps here for ground systems.
LD, go for launch.
That should be the last call out. The SpaceX launch director gave the go for launch. We're coming up on the T-minus 35 second mark. Everything is go. Let's listen in to the launch of Falcon 9 with mPOWER E.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon. Vehicles fishing downrange. Chamber pressure's nominal.
T plus 30 seconds, and Falcon 9 has successfully lifted off from Complex 39A at Kennedy Space Center. We're carrying the two O3b mPOWER satellites. We've heard the initial call out. Stage 1 propulsion is nominal, and the Falcon 9 is beginning the pitch
Power and
downrange.
telemetry nominal.
Avionics confirms power and telemetry coming from the second stage are nominal on Falcon 9. We're into the throttle bucket
Falcon
right
9
now.
is supersonic.
We've heard the call. We're supersonic. And engines have throttled back up as we're coming
Max
through the
Q.
period of maximum dynamic pressure. Guidance officer calls out Max Q, confirming we're through the period of greatest stress. 9 Merlin engines running at full power. Now on your screen, you can see on the left the speed and the altitude of the first stage. Stage separation will occur at about 8,200 kilometers per hour, and in order to get into the initial orbit, what we call the parking orbit, the Falcon 9 has to gain enough speed to reach about 27,000 kilometers per hour. That's a bit under the 17,000 miles per hour used as a rule of thumb for the low Earth orbit velocity. Now we've got several events coming up in about half a minute. We're going to have main engine cutoff. Then a few seconds later, we get stage separation, and then the second stage engine start number 1 called SES-1. During main engine cutoff, we're going to shut down the 9 Merlin engines, then we'll get the stage separation. And once we're separated, take a look in the daylight. You should be able to see the view of the first stage as we begin a slow flip to orient the first stage back towards Earth, while simultaneously the MBAC engine on the second stage will ignite for the first time.
Miko. Stage separation confirmed. Evacuation.
We've heard it and seen it. We've got successful main engine cutoff, stage separation, ignition of the second stage engine. Nice views late in the afternoon as we're leaving Florida, and maybe even a little bit of the contrail visible in the distance behind the second stage nozzle. And on the left side, you can see the first stage. Coming up now is fairing separation in about 5 seconds.
Fairing separation confirmed.
Well, we saw in the background the fairings separate. As we had mentioned at the start of the webcast, the payload adapter we use for the mPOWER satellites blocks the view of the camera, which is one reason the webcast will be ending once the first stage lands and the second stage gets into its parking orbit.
Vehicles are on a nominal trajectory.
GNC with the right call out, we're on nominal trajectory. We're coming up on 4 minutes into today's mission. Now, as I mentioned, if we were bringing the first stage back to a land landing, we'd do what we call a fast flip. That would quickly turn the stage around. But we're going downrange to the drone ship, so we do a more leisurely flip, and it's not quite as fast as we would do for a land landing. In fact, you can see the stage is slowly rotating. It's moving at a speed less than 1 degree per second. Now, coming up in 2 minutes, we expect to have views of the first stage's entry burn. And in the entry burn, we'll relight 3 of the M1D engines on the first stage. We start with the center engine, what we call E9, and then we follow it up shortly afterwards with engines 1 and 5. And that'll slow down the vehicle as it gets ready to pass back into the Earth's atmosphere. Now, we need to slow down in order to reduce that re-entry heating, and that ultimately helps us to recover and reuse the first stage. Now, if you've been watching, on the left side, you'll notice the altitude of the first stage has reached its peak. I think it got to about 123 kilometers, and now it's beginning the trip back down to the Earth's surface. Now, it took us about 2 minutes from stage separation until the first stage reached its maximum height, and it's going to take us another 2 minutes to come back down to the altitude where the entry burn begins. Now, this portion of flight is in the vacuum, and you can see the grid fins on the first stage view from the interstage camera. Not right now, we're looking on the inside of the interstage, but on the outside, you can see the grid fins. They don't have a function right now. They're deployed, but there's no atmosphere for them to react with. The grid fins come into play after the entry burn once we start to bite into the Earth's atmosphere. Now, during the entry burn, Falcon 9 is going to be decelerating by firing its Merlin engines, but it's not slowing down all that much. It's bringing it somewhat down, but that means that we're going to fly through Merlin's exhaust gases, what we call the rocket's plume. And that's what deposits that layer of soot on the vehicle tanks, which is why our flight-proven vehicles look so sooty. That comes from the fuel that Falcon 9 uses. Coming up in about 10 seconds, we should have entry burn. Wait for the call out, see if we can spot it on the camera.
Stage 1 entry burn startup.
Stage 1 FTS has safed.
Entry burn's begun. The center engine is lit. That's kind of the circular plume. And now engines 1 and 5 come in, and that's why the plume changes shape that you can see on your screen. Waiting for entry burn shutdown.
Stage 1 entry burn shutdown.
On time, we've got shutdown. Entry burn looks good. So now that we've completed the entry burn, the first stage begins entering the Earth's atmosphere. Now the maximum deceleration is going to happen in about 15 seconds. The first stage will experience about 5 Gs, but because we perform the entry burn, this portion of flight is not as difficult for the first stage. If we didn't have the entry burn, the first stage would have a tougher time coming in for the landing without compromising reusability. And reusability is key to lowering the cost of
Stage 2 is
spaceflight.
the terminal guidance.
Now coming up next, we've heard terminal guidance on second stage. We're now controlling the angular momentum state of the second stage. We're going to get MVAC engine shutdown in about 20 seconds. And then right after that, we should get into the
Stage
landing
1
burn
transonic.
sequence on first stage. Reminder, the first
Stage 2
stage
FTS
is
safe.
targeting a drone ship landing out in the Atlantic Ocean. Waiting for the call out for SECO.
Back shutdown.
We've got MVAC engine shutdown.
Nominal parking orbit. Stage 1 landing burn.
And both call-outs right on time. Guidance reports a nominal parking orbit for the second stage. The first stage has begun the landing burn. Headed to the drone ship on the power of the center engine E9.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
All right, and we have touchdown of formerly new booster on the drone ship out in the Atlantic. So there you have it. That landing marks SpaceX's 385th recovery of an orbital class rocket. That includes first stage landings for both Falcon 9 and Falcon Heavy. Meanwhile, the second stage, there's a great view, and I think in the distance you can see a little bit of the contrail in the upper atmosphere as we headed east out of the Cape just before sunset. And so we're watching the last glow of the sun as the second stage heads eastward into the shadow of the Earth. So second stage embarking now on the initial coast phase. The view you're seeing there, that's the payload adapter. The mPOWER spacecraft are just on top, but they're hidden from view. And so with that, we're not expecting to have great views of payload deploy, and we're going to end the webcast at this point. But keep an eye out on our X account for confirmation of payload deploy. That comes around the T+2 hour mark. With that, we want to thank you for joining us for SpaceX's 128th launch of 2024. All of us here at SpaceX want to give a big thank you to our customer SES for entrusting us with today's mission and for their ongoing partnership. We also want to thank Kennedy Space Center, the Eastern Range, and the FAA for supporting today's launch. And as always, thanks to all our viewers for logging on and your continued support. Remember to follow @SpaceX on X for launch updates. Thank you, and we'll see you again soon.